Assalamualaikum and a very good day. I'm Nur Farhanis binti Suhaimi with Nurul Ala Natasha binti Ahmad Nazri. We are student major in civil engineering from Polytechnic Sultan Azlan Shah. For International Multidisciplinary Innovation Competition IMIC 2021, we are going to present about a study on a modulus of elasticity of chipboard mixture from oil palm shell OPS waste and Meranti Temak Nipis MTN wood chips under guidance Puan Hidana binti Muhammad Yunus and Dr. Nurliza binti Muhammad. Malaysia is one of the world's leading producers of palm oil, which is multi-purpose and widely used commodity source in the world. In 2016, palm oil commodity revenue recorded a production of 21 million metric tons. Thus, waste oil palm shell reached 4 million metric tons per year. In the process of palm oil production, the shell is isolated as a waste that requires a special disposal space. The production of chipboard mixed with oil palm shell waste is a creative method to solve the problem of industrial waste dumping as well as being a source for the furniture manufacturing industry in Malaysia and environmental sustainability. Problem statement for this study is the dumping of industrial waste, which is oil palm shell OPS waste. As we know, Malaysia is one of the world's palm oil producing country, so this is not a strange thing if Malaysia face problems such as agriculture waste problem, especially in the processing of palm oil. So, the problem solving is the production of a chipboard mixed from OPS, oil palm shell waste, and MTN, Meranti Temak Nipis, wood chips. The objective of this study was to produce chipboard mix with oil palm shell waste, OPS, and Meranti Temak Nipis wood chips, MTN. This study also conducted to test the bending strength MOE of the standard chipboard with a chipboard residue mix with oil palm shell OPS and Meranti Temak Nipis MTN wood chips. This is to determine whether the oil palm waste is suitable as a mixed material in the production of chipboard, or the oil palm mix chipboard produced can be one of the materials in the manufacture of furniture, as well as an innovative product in the furniture industry. Scope of the research is a produce chipboard mix of OPS, oil palm shell waste, and MTN, Meranti Temak Nipis wood chips. The size of the panel produced is 340 x 340 x 12 mm. Sample size is 290 x 50 mm x 12 mm. Bending strength test MOE or Modulus of Elasticity is according to BSEN 310-1993. The ratio of OPS, oil palm shell waste mixture, and MTN, Meranti Temak Nipis wood chips is 70-30 and 50-50. The study period was 10 months, which is from December 2019 until October 2020. The importance of the study: first, solve the problem of dumping industrial waste such as oil palm shell waste. Second, to study the suitability of oil palm shell waste as a mixture material for chipboard production. The last one, to study whether chipboard mixed with oil palm shell is suitable as one of the material in the production for furniture. Okay, so let's continue with literature review. The material that we use is Meranti Temak Nipis wood chips and oil palm shell waste. First, Meranti, Temak, Nipis, MTN wood chips. Meranti, Temak, Nipis tree, or its scientific name Shorea roxburghii, is a native rainforest tree. The size of wood chips that we use and supposed to be is from 0.06 until 1.18 millimeter. This plant can adapt to both dry and moist soil. For oil palm shell OPS waste, oil palm, or its scientific names Elis guinis, is one of the plants in Malaysia. The palm shell is part of the palm fruit. As a result of the extraction of palm oil causing the dumping of oil palm shell waste. The characteristic of the oil palm shell are hard, smooth surface, and water resistant. Now I'm going to tell about chipboard production process. First, the oil palm shell is crushed using a crusher machine. Second, the oil palm shell and wood chips are placed in the oven to dry for a day. Third, the dried material are weighed according to the percentage calculated. And fourth, ingredients that have been weighed according to the ratio are put into a mixer to be mixed with urea formaldehyde to make sure it all glued. Fifth, the ingredients that have been blended are put into a 340 mm times 340 mm times 12 mm formwork. Sixth, the formwork is placed on the compaction machine for the material compaction process. 7. The compacted chipboard is placed on a heat compaction machine to ensure the materials adhere to the urea formaldehyde resin. And last one, once compacted, the finished chipboard is left to cool before being cut into samples. That's all from me. Let's continue with another presenter.
Hi, my name is Alieya Natasha binti Ahmad Nazri. I am a polytechnic student of Sultan Azran Shah Berang Perak, majoring in civil engineering. Okay, first of all, I will explain about the procedure of the pending strength test MOE that has been conducted, also the test result from the test, and the conclusion from the study that has been conducted. We conduct a bending strength test MOE on all three mixing ratios, on all three the resulting mixing ratios. As you can see, there is 5 steps of the procedure to make a chipboard. First, once the panel is cooled, the panel is cut into 8 parts according to each ratios to carry out the bending strength test MOE process. The chipboard is cut into size 200 times 50 times 12 mm for each sample. Each sample was measured and weighed to obtain data before the bending strength test was performed. After that, the sample is placed on the instrument machine until cracks on the sample are produced. The test analysis data were obtained and recorded by the computer, and the test procedure was repeated for each test sample. Okay, next, this is on the left. This is an example of a panel that has been produced, and at the right side is an example of the surface of the chipboard with a mixture of oil palm shell, waste, and Meranti Temak Nipis wood chips. Okay, next, this is the test result for the sample for each ratios: 100%, 70, 30, 50, 50 ratios. Okay, the bending strength test result is according to the standard BSEN 310-1993. Okay, the bending strength test is determined based on the cracking rate of the chipboard through testing using an instrument machine. The result of bending strength test MOE must be reached more or equal to 1800 MPa. The mixing ratio of 50% MTN wood chips and 50% OPS got an average value of 1397.33 MPa. All samples did not meet the standards because the data obtained were less than 1800 MPa. The mixture ratio of 70% MTN wood chips and 30% OPS got an average value of 1603.36 MPa. However, at this mixture of chipboard, there are several test samples that exceeds the standard. As you can see in the table at the right, there are several test samples of 70-30 ratios that exceeds the standard. Among the sample that passed the standard was the second sample with a value of 1861.79 MPa. Then the sixth sample with a value of 1997.62 MPa. Then the seventh with a value of 1895.49 MPa. And the last one, the eighth sample with a value of 2169.50 MPa. The main objective of this study is to make chipboard from a mixture of wood chips and palm shell that aims to reduce the dumping of palm shell waste produced from the palm oil industry. For the conclusion, this study shows that mixed chipboard of 30% OPS waste with 70% Meranti Temak Nipis wood chips has a slight difference of 10% with standard value of 1800 MPa. Can be accepted because several test samples that exceeds the standard and can use as one of potential new material in the furniture manufacturing industry. Last one, the suggestion that can be submitted from this study is to further the study on the bending strength test of chipboard with a mixture of all palm shell waste in order to obtain finding that meet the BSEN 310-1993 standards. Various disposal, afford and commercial value for waste materials such as OPS need to be further enhanced to ensure environmental sustainability. That's all from me. Thank you.